Hello, everybody. My name is Guillermo Melantoni, and I'd like to talk a little bit about what we do here in Tinkercad and how that can help with communication. So thanks a lot to the Ballet Design Cluster and the US Embassy in Malta for the opportunity to share a lot of the things we're doing on Tinkercad with all of you. So I'm going to share my screen now. And I just wanted to show you a little bit of the context of why we think all this is important. So first of all, I work and I'm the lead at a product called Tinkercad. It's a product for Autodesk. It's an online 3D design and electronics design tool, basically tailored towards young people starting in CAD. I mean, anybody can use it basically, but it's mostly beginners, I would say. Many makers are also using it. So it's a really, really nice tool that doesn't have the complexity of some of the professional CAD, but still has a lot of power. And I really want to show you why all this is relevant in these times. First of all, if you are right now at school or if you're a teacher, there's a lot of conversations around 21st century skills, which basically means what kind of skills do we need to get into the job market in the 21st century? The truth is that nobody really knows a lot of what's going to happen in some years from now, right? So even if you think about, for example, thinking 10 years, 15 years back, nobody could even predict that there will be so many 3D printers available for classrooms, for example, or in public libraries or at home. So many things have changed in the way that we look at design and also teach at schools. Also, think about electronics. 3-4 years ago, there were less electronic-based games at retail stores, right? So all of a sudden, there's a generation that has access to circuits, to 3D CAD, to 3D printers, to laser cutters, all things that were not available. I mean, not only when I was young, which was a long time ago, but also when like 10, 15 years ago. So imagine what will be available 10 years from now or even 5 years from now, we don't really know. So one of the most important things about this idea of the 21st century skills is how flexible is our learners to keep learning. Because there's so much happening around technology, automation, different systems, Internet of Things, cybernetics, robotics, all sorts of things that sometimes I think the big word there is automation, and it's kind of almost in red. It doesn't mean the danger, but somehow for some people, it sounds like dangerous that so many jobs might be lost to automation. Sometimes you don't think how many jobs will be created based on automation, which is the other side of things. And the question is, how are we getting prepared for that? So one of the things that are most important for us is, these are what some people call the 4 C's: critical thinking, collaboration, communication, and creativity. They are assumed to be some very important skills for this new world, right? So critical thinking, because you need to understand where you're standing, what's the context, what other things are coming, and just be able to take all that and improvise or find solutions for problems, right? So creativity is very close to that. Collaboration is, we have never been so connected as now, and we need to find out ways to working together. Communication, definitely, right? All of that together makes us so much powerful. And when thinking about some of the skills that we feel, or that education feels that are needed for this new generation, it's not only about solving problems, because that's kind of obvious. It's also trying to understand what is the problem and where is the problem, right? So the first step before solving a problem is actually realizing there's one. So articulating what is the problem to solve and then solve it, very important. And a hands-on experience as you do that, this whole idea of design thinking, in which you will probably fail a couple of times as you look for answers for something, iterations, prototypes, testing, this didn't work, go back, try something else. It probably worked a little better. So, and then iterations take you to the final thing. And of course, the digital and computer skills, right? So everything that's happening right now has some digital part. Of course, there's still analogic pieces, right? I'm not saying that we need to stop kind of doing textiles or cutting cardboard or anything, but the combination of the analog systems with the digital systems on the computer is super, super powerful. And that all leads to the idea of STEAM education: science, technology, engineering, arts. That's the A before people talked about STEM, and mathematics, right? And I'm very happy that the A got there, because it's also the arts and also the creativity and the design area, right? So this is pretty important, and it's at the foundation of a lot of the curriculum that gets you prepared for those 21st century skills. And in that context, why is Tinkercad doing well, right? So we just passed 25 million registrations actually yesterday, so we're super happy about that. It's really important for teachers, students, makers, and designers, right, that they have something that is powerful, but it's also easy to use. So in many cases, when you think about professional CAD, you need 10, 20, 30, 40 hours of training on the product itself before you start doing something with it. In the case of Tinkercad and other products, we have like Fusion 360, but Tinkercad more particularly because it's aimed towards a beginner. It's all about working on the problem. I mean, the commands that you need to know are 3 or 4, not more than that, right? So many things you already know them from the past. I'm going to show you that later. So, and it basically inspires a new generation to understand how to solve problems through design thinking. That's the most important thing. It's not about Tinkercad itself. It's about how Tinkercad can develop this muscle of, hey, I can solve problems and I can build something based on that solution, and I have that power, right? And that is really a magic moment in which you get empowered to not only just consume what other people build, but to design what you need. One of the most important things in terms of user experience for us is how Tinkercad is somehow taking elements and learnings that you have from things you've done before Tinkercad. So for example, if you're thinking about somebody, I don't know, that's elementary school that wants to start with Tinkercad, what are they doing, right? So they're probably playing with bricks, right? They might be playing with any modular systems like this kind of blocks, right? They for sure have some experience playing things like Minecraft, right? In which they get a sense of 3D space, but also they get a sense of adding and subtracting things when they're mining for blocks or they're building with blocks, right? And then they're also just starting to get used to gaming, and this is Roblox in this case, but also Roblox has a way to build game levels and stuff like that. So all of that is something they already know, right? The understanding 3D space is so much more intuitive for the new generation because they already have all those systems around. And of course, programming, right? Programming is something like Scratch that could be used for simple games, for simple things in 2D, but we have also adopted for 3D modeling and for electronics. So in the same way that at least in the US, in pretty much every classroom I've been on first or second grade, they have a bin with all these wooden blocks with people can build things. Tinkercad is somehow the counterpart, the digital counterparts to those objects, which is very interesting. And again, talking about mindset, of course, this is a chair, right? But if I asked anybody in the audience that are designers about how you will build a chair, probably they would think like this, right? Okay, this has 4 legs and maybe the seat, and it's just that piece there. Or sometimes they would say there are 2 different pieces, and they're already thinking about how to assemble all that. If you ask the same question to somebody that's being kind of using the previous elements, probably what they would say is something like this. That chair is made like that with 240 cubes, right? And this is kind of how kind of those learnings from the previous experiences come in, which is okay. And what we're trying to do with Tinkercad is sort of get started here, get started on building with those basic blocks, and then taking people slowly into the mindset of how you really build things. And when you think about that in terms of 3D modeling and being able to 3D print or to laser cut, and then also add all the electronic side, which means, for example, that you'll be able to add a sensor or lights or sounds to what you do, and also add logic with programming in the intersection of digital fabrication, electronics, and programming. That's a pretty awesome sort of mind-blowing moment in which you realize how much power you have in your hands. And we are very proud to, at least we believe, we are thriving in the whole ecosystem. We're not just providing an application for 3D modeling and 3D printing, or for doing electronics, or for learning programming. We're not a computer science application for learning computer science. We are everything. We are this thing that when you put all these things together, all of a sudden, the piece of plastic that you have probably designed can move or can react, right? And all those things just lead you into the path of product design if you ever want to get there. So, for example, this is something that happens a lot, right? So in many classrooms, especially, the first exercise is a name tag. So a name tag is an amazing first exercise for many reasons. First of all, it's basically a box with a cylinder at the end, with a hole and a name. You can make it more or less fancy, but basically that's what it is. So it's easy to model, it's easy to understand. It's very probable that the printing will be successful, because sometimes when the models are complicated and support material and everything, the printing can go wrong. So, and it will print fast because it's pretty flat. So print fast, lower failures on printing. It's modeled fast, and it's highly personal. It has your name. You can also wear it. You can put it on your backpack. You can brag about it when you go back home, right? There's so much you can do with just a simple piece of little plastic. But somebody could say, hey, what if at the end of that thing, I can put lights and something that translucent, right? Or that becomes my name tag, or I just do something completely different in which I understand I have so much more that I can do. And eventually that may lead in the future to somebody working in the field of mechatronics, which is basically just the idea of mechanical engineering and electronics combined. So from Tinkercad into other products in Autodesk like Fusion 360, we have this idea of the introduction to design concepts and best practices. So I can absolutely see that, for example, the girl that made all these models here might eventually get into a career 10 years later, right, around design. And this is all what you can do in Tinkercad, right? From simple interactions on an iPad with your finger, kind of painting this, but that becomes a 3D object, into making objects that can combine electronics and models. All sorts of things, right? From electronics to gadgets. In this case, this is Jordan, the same girl that made the designs on the other side. So she has a very specific challenge, which is she's missing an arm, right? So she had, for example, created this object that basically shoots glitter, right? So she just pulled this string here, and that would, as you can see here, the string is all around this object. So we'll take all of down, and then this will basically kind of blow the glitter into whoever was in front of them. Normally they're her brothers, and absolutely successful with that, to the point that then her next iteration was what we compressed air. So actually she could do it really faster and much further. So and she has a lot of interesting challenges, like for example, something as obvious as toilet paper, right? She has one hand, right? So all of a sudden that hand might be also wet. So how can she grab the paper to dry her hands, right? Because she doesn't have the other hand to help, right? So she has also designed devices for that. So again, articulating a problem, finding a solution, being creative, and not just depending on somebody else making something for you. That's the power of making, and that's the power that we feel, and we're very proud to believe that Tinkercad does that for people. So the 15 million here is old, so this is that's 25, so I should put a 2 here. But then coding, and in this case, a teacher that started getting his students to make t-shirts based on that code, so code you can wear, right? Some people have done this with chocolate, so it's code you can eat. It's amazing all the things people do. So, and that can again lead to the next phase, which is if people want to pursue a career in design, in product design, in mechanical design, something like Fusion 360, right? That gets you into simulation, into electronics design, into machining, right? Into production of real objects. So that's sort of the path, right? From the very beginning into the very end, if you want to get so far. I mean, if you just want to have fun building something and creating something in Tinkercad, that's also okay. Because at the end, what we're trying to do is just making design thinking be a part of people's lives, right? And create that emotional connection with what they do, which also encourages this idea of the lifelong learning.